Hello everyone and welcome back. In our previous lesson we learned about lists and tuples. Lists allowed us to store multiple values in a single variable, while tuples gave us a way to store data that shouldn't change. Today we are going to learn another one of Python's most powerful data structures called dictionaries. Dictionaries are used everywhere in programming. Whenever you work with user profiles, product information, gameplay statistics, bank accounts, or even contact lists, you will often find dictionaries being used behind the scene. By the end of this lesson, you'll understand what dictionaries are, how they store information, how to access and modify data, and why they're often a better choice than lists. We'll also build practical projects like a phone book or an inventory system. So let's get started. So let's begin with a simple example. Suppose we want to store information about a student. Using a list, we might write the following example, that student is equal to square braces ls20a. This works, but now imagine someone else is reading your code. Can they immediately tell what each value means? Does Alice represent the student's name? Does 20 represent their age or, well, even grade? Or does A represent their grade or their section? They would have to guess or look elsewhere in the program. To access the student's age, we would write print student and the index, that is 1, and the output would be 20. But why does index 1 represent the age? Nothing in the code explains that. This is one of the biggest disadvantages of lists when storing labeled information. Instead, dictionaries allow us to give every piece of information a meaningful name. Consider the example on my screen. Now the information is much easier to understand as each value has a key assigned to it, a name assigned to it. Instead of remembering index numbers, we use descriptive labels called keys. So what exactly is a dictionary? A dictionary is a collection of key value pairs. Think of a real English dictionary. When you look up a word, the word is the key. The definition is the value. Python dictionaries work in exactly the same way. Now here's an example. Now let's break it down. The key name has the value Alice. The key age has the value 20, and the key grade. Each key is unique. Each key points to one value. Python stores all of these pairs together inside a curly braces. Also notice that dictionaries use curly braces instead of square brackets like lists. To create a few dictionaries, here's an example on my screen. First, we will define the name of the list. In this case, I've defined it to be dict1, after which I'll use the equal to sign and curly braces, inside of which I will use quotation marks to use a string as a key, that is name, after which I will use colon and then the value I want to store inside that key. Remember that curly braces creates a dictionary, keys are written before the colon and values come after the colon. Every key value pair is separated by commas. Now let's learn how to retrieve information. Unlike lists, dictionaries don't use indexes. Instead, we use keys. Suppose we have the following example. Here I have a dictionary called dict1 in which I've stored two values. To print out the student's name, I am using print dict1 square braces name, and the output comes out to be Alice. And as you can see, the output is Alice. And to print the student's age, we just have to replace the name with the key age. Now let's run the program, and as you can see, it has printed out the age. Now notice how readable this code is. When you read student name or student age, you immediately know that you're accessing the student's name or age. Compare that to student 0 or student 1. The dictionary version is much clearer. Just like lists, dictionaries are mutable. That means we can change the existing values. Consider the following example. Now if I were to run this program, the age will be changed to 21. Python simply replaces the old value with the new one. So we just have to reference the dictionary name, that is dict1 square braces, and inside of those square braces you have to write the key equals the value you want to store inside of that key. Adding new information is just as easy. Suppose a dictionary looks like this. Notice in the second line, to add a value, I first referenced the dictionary name, that is dict1 square braces, inside of which I added a new key, that is city, and I've stored the value ABC inside of it. Now let's print it out. And as you can see, another piece of information got added. Now let's compare dictionaries and lists. Lists use indexes and are accessed using numbers and they store ordered values and they're good for sequences. Whereas dictionaries, they use keys. Accessing them becomes easier and more readable through using names. They store labeled information and they're good for related information. Now let's build our first dictionary program. With the example on the screen, define a dictionary called student in which store the set values, after which it is your task to print out the values that are given inside the output. Welcome back. In the previous section, we learned what dictionaries are and why they are useful. We discovered that dictionaries store information using key value pairs, making our programs much easier to read than using lists with numeric indexes. We also learned how to create dictionaries, access values, modify values, and add new key value pairs. But Python provides many built-in methods that makes dictionaries even more powerful. Instead of writing complicated code, we can use these methods to retrieve the data safely, view keys, values, and update information, and also remove entries. By the end of this section, you'll know the most commonly used dictionary methods and build your first phone book application. Let's begin. Just like lists have methods such as append and remove, dictionaries also come up with their own built-in methods. Some of the most useful ones are get, keys, values, items, update, pop, and clear. These methods save us time and make our code cleaner. We'll explore each one with examples. So firstly, let's talk about the get method. Suppose we have the following dictionary. If we want the student's name, we already know we can write print student square braces name. This works perfectly fine. But what happens if we try to access a key that does not exist? Let's see it for ourselves. As you can see in the second line, I'm trying to print out the value of city. But look closely, there is no city defined inside of my dictionary. So let's go ahead and run this program and see what happens. And as you can see, Python gives us an error, a key error. This happens because there is no city key inside the dictionary. Instead, we can use the get method. Now notice I've replaced and used student.get, inside of which I've written the city, inside of which I've written the key. Now let's run the program and see. Now notice that instead of crashing, Python simply returns none. We can even provide a custom default value. As you can see, right after the key, I've added a comma, after which I've added the default message that I want to be displayed instead of none. And let's run this and as you can see, the output comes out to be city not available. This makes get much safer when you're not sure whether a key exists. Viewing keys with keys. Sometimes we don't need the values. Instead, we just want to know what keys are present. For this, Python provides the key method. For example, as you can see, I've used student.keys, and let's see, the output will be only consisting of all the keys that I've stored inside of my dictionary. This tells us all the keys are stored inside the dictionary. This is useful when exploring large dictionaries or checking the available information. Similarly, if we only want the values, we use the values method. For example, I will just replace keys with .values. Now let's run the program, and as you can see, the values get printed out. Notice that the keys are not shown. This can be useful when generating reports or displaying information to the users. Sometimes we want both the keys and the values together. That's where the items method comes in. I'll simply go ahead and replace the values with the method items. And as you can see, each item is displayed as a pair. Later, when we learn loops, this method becomes extremely useful because we can process both the key and the value at the same time. Earlier, we learned to modify values like simply just using the dictionary name bracket, the key is equals to the value. Another way is to use the update method. Now let's go ahead and print it out. And as you can see, the update method can also add new keys. If the key already exists, its value is updated. If it doesn't exist, a new key value pair is created. To remove a specific key, we use the pop method. For example, as you can see, I've just simply written student.pop and the key that I want to remove. Now let's go ahead and run the program, and as you can see, it no longer exists inside of my dictionary. If you try to remove a key that does not exist, Python will raise a key error. Suppose we want to remove everything from a dictionary. We can use the clear method. Now let's run the program, and as you can see, the dictionary still exists, but it contains no data. Now let's apply everything we've learned and build a simple phone book. Now let's apply everything we've learned and build a simple phone book in which your task is to first define a phone book with the pairs of people and their phone numbers as their values. After which you have to take user input, in which they will input a string of numbers. After which you will use the get method to see if that number exists inside of that dictionary or not. And if it does not exist, you have to display a message contact not found. Pause the video and try it out for yourselves. Here's the correct program anyways. So we've just defined a simple dictionary with the names as the keys and their numbers as the values, after which I've used the name is equal to input to get the user's input, after which we also used the print phonebook.get name comma the default message to see if it exists, and if not, to display the default message that I've just described. So in the previous section we learned several useful dictionary methods, and these methods helps us access and modify the dictionary data efficiently. But imagine you have a dictionary containing 500 products. Would you manually write each print statement for every single product? Of course not. Just like we use loops with lists, we can also use loops with dictionaries. We'll also learn how to store dictionaries inside other dictionaries using something called nested dictionaries. By the end of this lesson, you will be able to display complete dictionaries, organize complex information, and build a simple project. Let's begin. Suppose we have a simple dictionary in which we hold three values, that is, the name, age, and grade of Alice, who is 20 with grade A. The simplest way to loop through this dictionary would be using a for loop. Now let's understand this through our example. So as you can see, I've taken a dictionary called student in which I have three values stored: the name, age, and grade of Alice, who's 20 with grade A. And I've used a for loop that is for key in students to print the key. Now notice something interesting. The loop will only print out the keys. That's because when we write for key in student, Python automatically loops through every key in the dictionary. Think of the variable key as changing during the first iteration. Key is equal to name in the first iteration, then it becomes key is equals age, and finally it becomes key is equal to grade. Now let's run the program and see the output. And as you can see, all of the keys gets printed out. Now, printing only the keys isn't always enough. Usually we also want the values. Fortunately, every key can be used to access its corresponding value. For example, now notice I've replaced the simple print statement that was print key to print key, comma, colon, comma, student key to actually access the value stored inside that key and print it out. And as you can see in the output, we get each and every pair. Now let's understand what's happening. On the first iteration, the key becomes name. So the student bracket key becomes student name, which returns Alice. The same thing happens for every key in the dictionary. And sometimes we don't care about the keys. We only want the stored values. For this, we use the values method. For example, instead of using the print key, we will simply use print value. Now notice the slight change I've made. Instead of using for key, I've used for value. So instead, the looping through the key on each iteration, it now loops through each value, thus allowing us to print the value. So now let's run the program, and as you can see, we get all the values. Earlier, we also learned that student.items returns every key value pair. This becomes especially useful with loops. So far, each value in our dictionary has been simple. For example, student name colon Alice and age colon 20. But what if we want to store multiple students? One option is to create separate dictionaries, that is, one for Alice and one for Bob, storing each one's age 20, marks 90. This works, but a better approach is to combine everything into one larger dictionary. Take the example on my screen. This is called a nested dictionary. A nested dictionary is simply a dictionary whose values are also dictionaries. Think of it like folders inside another folder. The outer dictionary stores each student's name, and the inner dictionary stores information about that student. Now suppose we want to access Alice's marks. What will we write? Similar to the nested lists, we use double indexing. We will similarly write print students square bracket Alice square bracket marks. So now let's run the program and see if we actually get the marks. And as you can see, we get 90. Now let's understand this step by step. First, the student Alice returns the age 20 and the marks 90. Then, using marks square brackets, retrieves 90. We can also loop through nested dictionaries. For example, now take a look at the loop. Hey, I've used for name comma details in students.items so that I can access the students as well as the information stored inside of each student. Now let's go ahead and print this out. And as you can see, we got the output in which the entire dictionary got printed out. So far in this lesson, we focused entirely on dictionaries. We learned how to create dictionaries, access their values using keys, use full dictionary methods, loop through the dictionaries, build nested dictionaries. But now we're going to learn about another important Python collection called a set. At first glance, sets might look similar to lists because they can store multiple values. However, sets have one very special property. A set can never contain duplicate values. If you try to add the same item multiple times, Python automatically keeps only one copy. This makes set perfect for removing duplicates, tracking unique visitors, comparing groups of data, and many other real-world tasks. Let's see how they work. A set is an unordered collection of unique values. Let's break that definition into three parts, the first being collection. Like a list or a dictionary, a set stores multiple pieces of data together. Second being the unordered. Unlike lists, sets do not keep their elements in a guaranteed order. If you print a set, the items may appear in a different order than you entered them. Thirdly, unique. This is the most important feature. A set cannot contain duplicate values. But what if we try to include duplicates? Where will the extras go? Python will automatically remove them. There are two common ways to create a set. Method 1, using curly braces. As you can see with the fruits example on my screen, I've simply written fruits is equal to curly braces with the elements inside of them. The second method to define sets would be using the set function. It will convert any list that we have into a set. So suppose we have a list of numbers is equal to 1, 2, 3, 4, 5, 6, 7, 8. But once I use the set function, we can convert it into a set. These are one of the most common ways programmers remove duplicate values. That is, once you can have a list containing many duplicate values, after which you can simply convert it into a set and it will remove the duplicates, and simply you can again reconvert it back into a list. So you got a much cleaner list with no duplicates. Sets can be modified, so let's add a value to a set. As you can see, I've defined a set called fruits is equal to apple and banana, after which I've used the add method, fruits.add mango. Now let's see if it actually gets added to my set or not. And as you can see in the output, it does get added. Now let's try to remove an item. Instead of me using add mango, now let's use fruits.remove banana or remove mango, and let's see if it actually gets removed. Now let's run the program. And as you can see, banana has been removed. Now, there are two methods to remove an element from a set. That is remove and discard. Both methods remove elements, but there is an important difference. Suppose we have a set called fruits is equal to apple and banana. When we use remove and we use a value that does not exist inside of the set, for example, orange, Python will give us an error because orange isn't present. Now, if we try fruits.discard orange, nothing happens because no error is produced. So remember, remove raises an error if the item does not exist, whereas discard safely ignores the missing values. So whenever you are unsure whether an item exists, discard is often the safer choice. To remove every element from a set, we use clear. Now let's try it out for ourselves. Now if I run this program, every single element gets removed. And as you may also have noticed that similar to others, that is similar to the lists, the set will still exist even if I clear every single element out of it. It's simply empty. Sets also support mathematical operations. So let's create two sets and let's compare them. So as you can see, I've created two sets, that is A and B, with integers inside of them. Now let's compare them using union. Union combines all the unique elements. To print out union, we just have to use print A pipe B. You may be wondering what pipe is. I usually call that straight line a pipe. So everything from both sets will appear once in the output. And as you can see, even though we had some similarities between the sets, we only got unique numbers instead of duplicates. We can also perform intersections to find common values. For that, we just have to simply replace the pipe with ampersand to actually do the intersection. Now let's go ahead and save this program and run it. And as you can see, the common values, that is 3 and 4, are returned. Similarly, we can also do the difference. Difference returns the values that exist in the first set but not in the second set. To actually get the difference, we just have to use the minus symbol. So I'll just replace the ampersand with the minus, and let's see if this works. And as you can see, we got 5 and 6. Notice that the order matters in the difference operation. It is not unordered. So let's review what we've learned. Today, we learned that what a set is, why sets automatically remove duplicates, how to create sets and add and remove elements, what is the difference between remove and how to clear a set, how to perform different operations like union, intersection, and difference. You now understand Python's second major collection type and know when to use a set instead of a list or a dictionary.